I'm going to go over two-dimensional arrays. I'm going to introduce them. Two-dimensional arrays are what we would use to implement the type of things like tables. Right, so they have rows and columns. Now, two-dimensional arrays in Java are actually arrays that contain arrays, and I'll try to illustrate that here. Here's how we would declare a two-dimensional array of integers. We write int, two sets of brackets, one for you can think of the first one as how many representing rows, and the second one is columns. Here we give it a name, list. Then we actually use new to allocate the memory. And here we say how much memory. So we need 5 rows and 4 columns. Now what that's really doing, it's creating this big array, this one, right, with 5 elements. That one, that one, that one, and that one, right? So you can think of that the way you think of just a single-dimensional array of integers, right? But instead of storing a single integer in each of these cells, we're storing an entire other array of size 4. Okay? Now, we can isolate a particular array, a subarray here, by using this notation. List sub 0 gives us this array, right? And but it gives us the entire array, not any of the elements of that array. So to get the elements, we would need to specify, in addition to the row of the bigger array, we would need to specify within the contained array which column. So if we wanted the first one, we would do list sub 0. We want the 0 row, and we want the 0 column, right? And that would give us that one right there, right? That first 0. And so on, right? So we can actually, if we want to refer to the containing array, we call it list. If we want to refer to a contained array, we say list sub 0, that's the contained array in the first cell of the containing array. List sub 1 is the name of the array contained in the second cell of the containing array. Okay? A little confusing, but I hope that makes sense. Now let's look at some code. So here I'm declaring a two-dimensional array called board, and it has 10 rows and 12 columns, right? I could also declare an array like this by listing basically each subarray. So here's the first row, 1, 2, 3. The second row, that and this. Now notice they do not need to be the same length. So coming back to here, these arrays that are contained within list could be different lengths. They do not have to all be the same length, right? They usually are, but they do not have to be. Important point. All right, so there we've two ways of declaring these arrays. Now, within the constructor here of this class, more array fun, I want to fill the this array that I've created, because it's ints, all the cells contain 0 to start with. So, but I want to fill it with 10. So each of the cells contains 10. So notice how you do this. Use this nested for loop structure. This is very, very common when dealing with two-dimensional arrays, right? And so here I'm going to move, R stands for row, I'm going to move down through the rows one at a time. And then for each at each row, I'm going to move across through the columns. And at each row column position, I'm going to insert 10 into the array. So using this as an example again, right, I'm going to move down through my rows. These are my rows. Right? And at each row, I'm going to move across. That inner loop will move across through the columns. And then the outer loop moves us down through the rows, and again we move across through the columns, and so on. Right? So, outer loop in this case moves us down through the rows, and then at each row we move across the columns, accessing each cell within that inner array and setting it to 10. So let's pile that, and I have a, well, let's actually inspect this first. Let's see what we get with inspecting and our board. And as you can see here, this is actually very useful. The 0 element of the enclosing array board contains another array. That's what this arrow indicates, right? Arrays are objects, and whenever objects are referenced in a variable in the BlueJ inspector, you get this arrow. So let's go look at that subarray, and there it is, right? It's all those 10s. That's how many columns. There are 12 columns, and numbered 0 through 11, and they're all set to 10. Right? And if we looked at any one of these, we would see the same thing. Those are those. Now we're looking at the subarrays. Going back to this, we're looking at these guys. We first looked at that one, right? And then by double-clicking on the arrow, then we looked at that one. So I have a method here that will print matrix, and it prints out the matrix, all, or the two-dimensional array, right? There's that first subarray at the 0 position of the enclosing array, and so on down, right? Let's take a look at that code. So print matrix. So again, this nested loop structure, right? Outer loop moves you down through the rows. Inner loop moves you across through the columns. Right? You don't have to do rows first. You could do columns first if you wanted to. It totally doesn't matter. But usually, often you're doing row, column in that order. So rows are going to the, now here, this is important. We're going to board.length. Board is the enclosing the outer array, right? And we can get its length. And here, we're doing, we're going across through the inner array. And remember, the inner array is the name of the outer array sub 0, right? That's that inner array. And then we can get its length, which in this case is 4, but in our case, it's going to be 12, right? So then C is going to move from 0 to 11, and with R, the first time through being 0, so it's row 0, cell 0 in the enclosing array, and then in the interior array, we're going to move C through every value between 0 and 11. Now, notice that I'm using system out format here, and this allows me to specify how I want the output, the integer, to be formatted. So this just means I want it to be printed, the %5 means I want it to be printed in a field 5 spaces wide. And I forget what the D means right now, but you can look up system out format and find out what exactly that means. And then after I've printed across that whole row across, then I do a system out println, and that will force me down to the next line. So now, also want to look at printing this matrix, board 2. Now that, if I try to print board 2 with this formatting, it's going to cause a problem because each interior array has a different length, right? So yeah, so the first one is of length 3, the second one is of length 4. So if I use the length of the first one here, it's going to cause a big problem. So what I can do here is, instead of using 0 here, right, assuming that all the interior arrays are the same length, here I'll ask each interior array. So one at a time I say, hey, what's your length, right? In this case they're all 4, but they don't have to be. And then I will ask, what's your length, right? And it will tell me. And so that's what the R is there for, right? Because the R is going through all the rows, and at each row I ask the interior array, hey, what's your length? And it tells me, and then I can output it without worrying about running over the end and getting the dreaded array subscript out of bounds message. Remember, we never want to have a value here in our subscript that's outside the legitimate bounds of the array, or you get the out of bounds error exception. So let's just look at that. And oops, and we will print matrix 2. And there, that worked beautifully, right? That's the first subarray, the 1, 2, 3. That's the second subarray, 4, 5, 6, 7. That's in cell 2 of the containing, cell 1 of the containing array, and 8, 9 is in cell 2 of the containing array. Okay? So I think between this and the book and the Stanford lecture, you should be getting a good sense of how two-dimensional arrays work. You're almost always using the nested for loops, right, to move through them. You can get, here you can use the name of the matrix, the two-dimensional array, and get its length, because that's actually referring to the containing array. And then for each of the subarrays, you can get their length by doing this. If they're all the same, you can just say board sub 0. If each one happens to be different, you could say board 2 sub whatever your outer loop variable is, and get the length of each subarray before you go and print it, and therefore avoid any of the dreaded subscript out of bounds arrays, messages, exceptions. And remember, system out format is just a variation on system out print, in which you have to specify how you want your value printed. And you can Google system out format to find out all the different options. But in this case, all you need, if I wanted these to be printed out in each number to be printed out in a larger cell, say instead of 5, I would do 8, right? And I'll show you what that will do. Compile, and we'll do print matrix, and you see it just spreads things out a little bit more. Right? So that's, yeah, two-dimensional arrays. Hope that's helpful.